good talks. Go ahead and get started. Quick intro. My name is Dan Kuykendall. I'm one of the founders and the CTO of NT Objectives. We build a web scanning tool. I do some blogging on Man vs. Web App, podcasting there as well, and on InfoSec Place. Although we haven't done that many episodes lately. But much more importantly, I was this year's league winner for our Hackazon Fantasy Football League. After coming in 11th place last year, I was quite happy about this. So I was like smacking down Matt Joe all season, so it was very fun. Okay, so what we're going to be covering is a little bit of history on AppSec and kind of around the tools. We're going to cover our Hackazon tool, which is a new vulnerable testing app. But I think it helps to kind of give a little bit of history as to why it's needed, and so we're going to go through that a little bit as well. So if we look at some of the perceptions, even Hollywood perceptions have changed. We've kind of moved from being some odd kids to hunky action stars, so that's cool. We've made progress. So AppSec research in '99 was pretty. That's really where we were hitting a lot of the fundamentals. Most of this came from RFP, Rainforest Puppy, and some of his, we call him the father of web app security. Those issues in Frac magazine, if many of you remember this, right? This is back in the day, really kind of started teaching us about the issues with CGI security back then, right? The CGI problems. So, these SQL injection attacks that he kind of documented, those were in '98, and then he had some OS injection in '99. These things were the starting point. This is where we really started to understand that we could do these kind of injection attacks on web apps. And prior to that, it was just a bunch of static HTML pages. We weren't really thinking about it this way. So he kind of really set some of that foundation down. Cross-site scripting arrived in 2000 with the, it was like CERT's second listing that year was the first cross-site scripting attack that had been published. So, this stuff, this is what we see. Everybody's seen this example basically, or something similar from the moment you entered web security. This is from 2000. Nothing's really changed. Hacking the apps was always around kind of looking at the name and value pairs of the parameters, right? So you have your, after the question mark on the URL, which would be your get parameters, or in the forum posts, you have your name and value pairs. Everything was kind of built around that. And attacking them has always been very simple. You're really focusing on the value in that pair and applying attacks. So our understanding of it was pretty basic. Coming to today, when we're hunky action stars, There's a whole bunch of us hunky action stars here, right? There's a lot of great thinkers in this space now. RFP really kind of started us, but there's been a whole lot of people since. A lot of smart people. There could be many more pictures, but they're really small. There's a lot of people really focused on understanding this, and there's a lot of new organizations, right? There's OWASP and WASP, or WASP and WASP, around kind of helping us define this area and understand it. So this is all good stuff. We're making progress. The vuln types have grown from SQL injection, cross-site scripting, and OS injection. We've got all kinds of new attack payloads, all kinds of new things we're trying to do. Of course, cross-site scripting, SQL injection, command injection, they're all still living with us. They're just now classics, like our music is. Even the web development, we're going to kind of get into that here in a minute, has really changed. The applications are no longer just HTML-based, no longer just CGI. We've got very dynamic, complex applications, a lot of AJAX, web services, all kinds of stuff. We're going to get into that. But all of this has really kind of changed what's happening in the web app world, but development hasn't changed as much. So going on to the development and the security tools, back in the day, this is the tag cloud basically for web development. It was very basic, but HTML, some CGI, some get and post. Eventually we started getting active server pages, PHP. We started getting other stuff kind of coming along, but it was all still very basic. The complexity of these web apps, and then the DAS tools, the automated scanning tools, there was a bit of a gap, but it wasn't that pronounced. As the scanners had to start dealing with the frameworks, it kind of moved from being known vuln testing tools, like a standard network scanner, to actual application scanners that are focused on the app. There was a bit of shift because we're no longer dealing with known vuln checks. We're now dealing with having to kind of crawl this unknown thing and then start attacking it and trying to find vulns that, basically finding 0 days on its own. So it really kind of changed our game. And kind of, I was in the Foundstone team building the FoundScan product and kind of having to shift the mindset. It has been difficult, and that was something that took a long time. But they started doing that. So early 2000s, late 99, 2000, that's when the scanners started coming around. So a little history on them. Spy Dynamics, that was kind of the first one out there with WebInspect. And they eventually are now part of HP Fortify. They were in 2000. Covidu, which became Watchfire, which became IBM AppScan. They started in 2000 as well, but they didn't release their first web scanner until 2002. Sensic was 2001, with their scanner in 2002. And then our company, we started in 2002, launched our scanner in 2003. But we were all built back in our infrastructure of the scanners was all built on that old premise, that old ability to kind of crawl the individual pages, look at the request, look at the name and value pairs, and then create attack payloads on those name and value pairs, right? So, building the scanners, they're all built on that premise, and that becomes kind of a legacy problem that I'll get into. We ended up kind of re-engineering our scanner a couple years ago, 2014. Actually 2013 when it was released. But we had to re-engineer our scanner, and I'll get into a little bit of it. But it kind of sets the tone as to what's been changing and how the automated tools need to start catching up a little bit. So we look at today. In our current web development, we've got all kinds of stuff. I showed this earlier. Where we've got all this different traffic. We've got flash promoting with AMF. You got Google Web Toolkit, for some of the AJAX stuff. A lot of JSON. These REST interfaces. You got mobile. There's a lot of new technology that web developers are using. So we don't have just the traditional web apps anymore with the HTML. We have all kinds of stuff, right? HTML5 brings us WebSockets and local data storage. There's all kinds of new stuff that we have to deal with. Also, the application functionality is different. So we have, the various application workflows, and I'll show that a little bit. Anti-CSRF tokens. You got all kinds of new stuff that you have to deal with especially for automated tools and for manual pen testing. But you really have a lot of new stuff to have to worry about. You can't just simply crawl in the same way. There's a lot of hurdles. There's a lot of what we call crawler traps. You know, if you're going to scan an app, you have to be able to navigate all of these things. You have to be able to handle custom 404 messages that, you know, return a 200 code. You have to be able to deal with all this stuff. And it causes a lot of scanners some problems. And a lot of scanners will tell you, well, you just got to train the scanner. And you got to train the tool. And I think that is a failed option out of the gate. Because whoever's running these scans often don't know the application. You could be in an organization, you've got hundreds, thousands of applications. What's the chances that you know the ins and outs of every one of them? It doesn't exist. You don't have time. You need to spend your time on things that automated tools can't do, right? The privilege escalation and those kind of things. You want to be focused there, let the automated tools do their job. So I really try to push away from this, you know, okay, just train it, right? Let's just do everything in Burp. It's ridiculous. Right? Burp is fantastic for the manual testing, but you need automation to do its job. So there's a lot that we push on there. The complexity of these apps, right, going back to this chart, has now expanded considerably. So as the development models have changed rapidly, the automated scanner's ability to handle them has not improved as much as it needs to. There's a big gap in what can really, you know, what they can cover. So, you know, this is an area we push on quite a lot, and we try to talk about quite a lot because you need to understand what scanners can and cannot do, right? And I'm not trying to pitch our product. We have kind of closed that gap. We've kind of re-engineered to start closing it. We still haven't closed it all the way, and nobody has, but we're getting better. We're trying to push on these things. One of the key things that is really breaking scanners is that the format of data has changed. We're no longer just dealing with the name and value pair structure. We have these, you know, custom URL structures, you know, SEO-friendly ones. You've got the, you know, REST interfaces that are using XML, using JSON, got Flash and Flex, Google Web Toolkit. You've got all kinds of formats that the data is in. And if the scanner, which, you know, the scanners are all engineered back in the early 2000s, their whole engine was built around a name and value pair structure. Right, all the tools are built that way. Now all of a sudden you're introducing these, you know, nested data structures that are more complex, and the scanner's internal engines aren't up to the task. They're really built around a name and value pair. They don't understand how to deal with this. Even the WAFs, you know, going on the defensive side, WAFs don't handle this stuff, right? The easiest way to attack somebody that's got a WAF is find their REST interfaces, because the WAF is doing nothing. They're useless. So, you know, scanners generally handle traditional web apps, mobile-friendly web apps, which are still HTML-based, that, you know, to look good on a phone. They can handle some of the rich internet apps, but as they're hitting their REST interfaces, they really start to fall off. So these are kind of areas where we got to understand this as a community and be able to deal with it. You know, some of it's going to be manual testing, some of it's going to be finding tools that can handle this stuff, or pushing vendors to support them. And then mobile apps. You know, everybody's really generally focused on the mobile device and the app sitting on there. But to me, those REST interfaces that mobile app is communicating with, much more interesting. So this traditional model doesn't work out. What we had to do was kind of extend this model with what we call a universal translator. I think everybody's going to be moving down this path. Because what we basically do is say, okay, we can still do the crawling, but it needs to feed into an engine that has the ability to parse all of these different formats, understand each of these different formats, kind of come into a common structure, also take in recorded data, so I can take in traffic from a mobile app or some, you know, the REST interface, they've got some client to it. If I can record that traffic, feed it into the scanner, it'll identify the format, and then be able to go off and start attacking those interfaces. So you really need to kind of expand the thinking on these engines. We've already done this in our tool. I think everybody's going to eventually start doing it, but it really requires kind of a you know, paradigm shift in how the scanner is built and how it understands the traffic of, you know, apps today. So, you know, I mentioned earlier that depending on training is a failed option, right? But now all of a sudden I'm saying, okay, let's train it with recorded traffic. The problem is, especially with REST interfaces, a lot of people don't have these REST interfaces documented in a useful form. They have Word docs, and there was a talk yesterday about this. They kind of went into more detail, so I'm not going to cover it thoroughly, but a lot of people have these REST interfaces, and they'll have like a Word doc that describes how to use it. Okay, great, that's good for maybe another developer, but it's not any use for an automated testing tool. There are things that can help. So there's WSDL 2.0 was extended to support being able to describe a REST interface. WSDL is generally for SOAP, but you can actually describe a REST interface. Now, of course, it's WSDL, so it's ugly as hell and a mess to deal with, but it's there. WADL was actually created for REST interfaces, so that's there. It's an XML format, kind of similar to WSDL, but it's really just set up to just define REST interfaces. It's got very little adoption. I think it's basically going to die because nobody's using it. So what's come along is Swagger, and our little Swagger guy down here. It's JSON based. It looks like a JSON string that describes the REST interface. It's got a lot of very useful stuff going on, a very active community that's developing it. You can describe your REST interface actually in code, and it'll generate the little JSON. And then that actually can be used to generate documentation, like printable documentation, and it can actually generate clients right off of the code base. So you can, there's different, whatever programming language you're going to build your stuff in, you can actually auto-generate the basic client. So it's very powerful. I like Swagger a lot. And tools need to, automated testing tools need to be able to take in, WSDL, WADL, Swagger documents to be able to then auto-generate those requests against the backends. So anyway, I think this is the area where training is still required, but we want to move away from that. We need more and more automation. And also make sure, as you're kind of going through and testing different tools, that I've seen plenty of scanners say they support JSON, but again, remember, most of the scanners were built a long time ago, built around the name and value pairs, and they try to kind of convert their existing code and kind of wedge it over. And so what I've seen a few of them do is say, okay, we support JSON, and if you send it like a very simple JSON string, they'll kind of convert it internally to name and value pairs, and then be able to attack it. The problem is that only works in very basic situations. Most of the time, JSON, when you're using it, is because you have complex data to send. And so if you've got this nested data structure, they just fall apart. So they're not going to scan anything. So you want to kind of make sure that your tools kind of handle this stuff. Either automated or manual, you want to make sure that you can actually get in and attack the individual parameters. So this is where it gets interesting. Okay, so this is really where the heart of what this whole talk about is with Hackazon, is around the vulnerable test apps. There's been a lot of vulnerable test apps over the years. Really kind of started off, and Jeff Williams in the room next door created WebGoat. Right, this was back in 2002. Pretty much, how many people have used WebGoat? Like everybody, right? It's old, it's kind of lame, but it still does what you kind of want it to do as far as learning the basics, right? It's very good for learning how to do web security and having a test platform. It's not very good for kind of like comparing automated tools, because it's a very static thing. It's not very realistic as far as like a real app. And it's too easy to kind of create known vuln checking against WebGoat and find 100%, surprisingly, which would never happen. So it's not good for that, but it's what we have, and it's what's been around for a very long time. It's a good tool for what it is. Jumping forward to today, we have so many vulnerable test apps that we need lists, like the VWAD for that OWASP is hosting. There's a lot of vulnerable test apps for a lot of different purposes. And like it says here, this is how standards expand, right? It's like somebody complains like, oh, why is there so many? We need a unified, and then we create new standards. So we see this sort of thing a lot. However, there's reasons, and it's okay. So the VWAD actually has two lists. There's like the offline list, the stuff you can download and install yourself, and there's a lot of good apps there. And then there's one of these is online. Oh, Yeah, there's VMs. That's when you go from our off. Okay, these are actually the online ones. Whatever. You can go look at the list, but there's online lists, there's an offline list, there's some virtual machines that you can get as ISOs, there's a whole bunch of different ones. They're great. And they all generally have some very good things that you can do with them. You can go in and really learn about dealing with web security. So a few notables, of course, WebNode's still there, and they are updating it finally. Although they keep saying it's going to come out, and it's been a long, long time it hasn't come out. But WebNode is eventually going to be updated, but it's still there. It's now part of OWASP. There's the Hack Me Bank, books, casino, shipping, traveling, all the Foundstone stuff. You know, shortly after I left, and I kept begging them to do web security, and they weren't interested. After we got into web security, they realized it was kind of cool. So they started doing stuff. Those are actually very good tools. They have some very fun things that you can do. And again, they look like real apps, which is what I kind of like over something like WebNote, which is really a training environment. And then there's the Damn Vulnerable Web App, which is very good, does some cool stuff. I think it's much more popular than it ought to be, just because it has a cool darn name, so everybody likes the DVWA. But it's good, and it's actually fairly good for kind of testing tools as well, testing scanners. But it's a good little set there. There's some that are actually designed for testing automated tools. So there's the WaveSep. There's WaveSep, which was created for a report that Shay Chen was doing to kind of compare automated scanners, and both open source and commercial. And so it was designed to kind of test what vulnerabilities these scanners could find. And there was some, HTML gauntlets and JavaScript stuff you had to kind of navigate through. That was fairly cool, but it's still limited, and I'll get into a little bit of why. And then there's Wibbit, which doesn't really have vulnerabilities. It just tests a crawler's ability to get to places. Okay, so it's got all these, that's really what's like, does it handle JavaScript doing this? Does it have JavaScript doing that? All these different crawler problems. It kind of tests if you can get through it and get to the destination. One problem with this is it's really easy to cheat, because as long as you just know the list of URLs that you're going to eventually land on, and you just make a request there, it counts. So Wibbit's kind of useful, but and I actually modified the code and submitted the changes to the repository, so it actually kind of randomizes the destination pages. But those tools are kind of good for their individual little things that they do. The problem is that all of these scanners, all of these vulnerable web apps, have really kind of stayed with classic Web 1.0 technologies. They're still just generally basic HTML, maybe some bit of JavaScript, but they're just sending traditional gets and posts, got links and forms. They really have not modernized the look and feel and the activity that's going on in the application. So as we want to move forward, and what I was looking for is something that kind of lets us see what today's apps look like. When I'm doing assessments, when I'm doing work with our customers, the applications are much different. They are very dynamic, very rich, all the AJAX, they got mobile components. So here comes Hackazon. I finally decided we need a tool as a community, a vulnerable app that reflects what today's apps look like. So Hackazon is a fake app test site type of site, so it's kind of like Hack Me Bank and Casino. It looks like a real site, although Hack Me Casino is the tackiest thing in the world, so I don't think there would be a real casino like that. But it at least tries to look like a casino site, or there's the banking site. So we try to replicate that style, where it's a fake app. It is an online storefront, that's why it's called Hackazon. And it includes a mobile app. It's a little companion app that uses the REST interfaces of Hackazon to do its work, and I'll show all this stuff. But it's a modern-looking app, and we're going to actually look at it here in a minute. It's generally pretty easy to install and configure. There's a little wizard that kind of gets you through the install. It's pretty straightforward. So I'll list this stuff here later, but it's a basic LAMP type of application. It's pretty straightforward to get. It's all open source. We're going to be donating the copyrights to OWASP once the dust settles on the code. But we're actively developing it. We've got a few people working on it, and we're having a lot of fun kind of building it out and just kind of getting it to be something that not only can you test automated scanners against, but really you can use for the training, like WebGo. You can actually stick people on it. One of the very cool things, it's got the AJAX activity, it's got the HTML, it's got the AJAX interfaces that the REST interfaces that AJAX uses, that mobile uses. There's a lot of different technologies. There's like some Google Web Toolkit here, some JSON over here. There's Flash components for like banner ads. There's a Flash component that uses AMF for like entering the coupon code. There's actually some strict workflows. There's a lot of different stuff going on here that, again, stuff that reflects real applications. And the other very cool thing, and we'll get to this, is that the vulnerabilities are configurable. So you can actually go into the admin screens and decide which vulnerabilities this install is going to be vulnerable to. So, if you're doing this in a classroom environment, you can have, 10 systems set up with different vulns and say, go find it, go find what's there. And you put people to different tasks. And if you're testing automated tools, again, you can see if they try to cheat. You go, hey, it's Hackazon, here's the vulns. Like people do with WebGo. So it really kind of becomes fun in that way that you can kind of adjust this thing to your needs. Also, if you're not, let's say you're not doing any Google Web Toolkit stuff, then you can turn off all the vulns that are available through the Google Web Toolkit sections so that it doesn't, you don't find vulns that you don't care about, basically, and that aren't applicable to your environment and who you're trying to teach. So workflows, just so you understand what this is, we see workflows all the time, and this is a very simple one. It's a storefront. So an application workflow in this case is the shopping cart. Okay, the process of going through and saying, okay, I need to go through this sequence of events to do a checkout, right? Add an item to the cart, view the cart, checkout button that's going to ask me for my shipping info, my billing info. I'm going to eventually confirm my order and I get a receipt, right? That's kind of a standard process we've all been through a bazillion times. One of the problems here, especially with automated tools and the manual process, is that a lot of automated tools will allow you to train them to this workflow, but they're really just learning that for the discovery and crawling process. But if you think about it, if I go through this entire workflow, after I've submitted my order and I get my receipt, my session is reset. I have nothing in my cart again. I can't start attacking later on. I can't go and start attacking step 4 in this sequence if I haven't set it up. It's going to reject me. It's going to say, why are you attacking the shipping page? You don't have anything in your cart, right? Well, it doesn't think you're attacking, but why are you here? Go away, right? And this is something you're going to see in a lot of apps that you're dealing with. You really have to be able to respect the workflow. You have to set it up. You have to go through and add an item to your cart, view your cart, check out shipping info. Then you might attack, you might attack the shipping info as step 4. But you have to set all these things up, and you need to either know that you as the human tester have to do this, or your automated tools need to be able to handle this process. Most scanners can't do this. So you need to kind of go through, and sometimes you even have to follow through further. Because let's say I go through and I set it up, I do an attack, and maybe the payload actually is going to work. But let's say the data, let's say I attack one of the last name field here in the shipping info. It might be stored in session state at that point. It's not going to be committed to a database, a SQL database, until you actually confirm your order. So it's not until you get to the end that you might see the error show up, right? So you have to follow this through. And you have to be able to kind of set it up, do the attack, and follow through. And either the human pen tester has to do this, which is miserable, or your automated tools have to be able to handle these kind of workflow situations. This is very common stuff. And this is kind of the things we wanted to do with Hackazon is, we'll get into the actual using of it here in a second. We wanted to kind of replicate a lot of this functionality that is very realistic, so that as you're going through and cutting your teeth on these things, that you can actually get in and deal with it. So, so here's Hackazon. Let me actually put on short proxy. Just make sure I'm going through it. All right, so, basic stuff. It's a standard GET request. It's kind of somewhat clear. Given an HTML-based response, no big deal. There is this AMF traffic. It's I don't know if you guys are familiar with AMF. It's the action script messaging format, so it's what Flash uses to communicate with its backends. And so it looks like binary data when you're looking at it, but it can be decoded, and Burp actually has a decoder built in. And so you can see that it's requesting something here, and it's getting back, and it's going to get back a binary response, but again, decodable. So it's getting an image for this banner, oops, for this banner down here. Yeah, so this little thing here has got a few images that it can cycle through, right? This time it actually got 4. So it was asking for 4, and we got 4 different pictures back. But this is, this is stuff you can actually play with and attack. I might take this request and send it to, I go to repeater, here's the request, right, it's 4, and I send it, I'm going to get back 4 different pictures, is what I'm seeing here, right? I could change this, so let's say 2. Send my request, and I should get 2 pictures back. I could potentially toss in a little SQL injection single quote here. All right, a little single quote, you can see it. A little single quote in front of the 2. It looks like it handled, oh, try it at the end. This is actually defending itself, okay. Some of the other ones aren't. Now I gotta look at what's vulnerable here. But, you can actually go in and attack these things. If I do, let's say I'm here on my front page, I'm going to add something to my cart. I'm going to click on a little button. The page isn't reloading, but you can see that it's showing items in my cart. That's some simple request here is actually there's a REST request, but it's passing name and value pair structures, but it's getting back JSON. This JSON is actually what's used to render this thing up here on top. All right, so this is the kind of stuff you're going to see in real apps, and you have to be able to really start getting in there and attacking. There's all kinds of stuff. We've got the Contact Us page. It's got some Google Web Toolkit here, so I can... Actually, no, this is a JSON. So I can submit something here, and it's just thank you for your question. And that was actually sending data equals and a JSON string, right? So you, as a tester or your tools, have to be able to handle these nested data structures, right? Which add more complexity. And I see some crazy ones. I'll see ones like this, where it's data equals a JSON string, and then within the JSON string, one of the values is like an XML node or a comma delimited node. It's like, what the hell did you just, keep it all in one? But you see these things, and again, either you, the tester, or or your tools need to be able to cope with this. Right? If I wanted to take and attack this, again, I can send it to repeater, and I might come in here and I don't know. Let me see the contact name is vulnerable. I'll put just a single quote here in the contact name and send it, and I'm getting an error. Yeah, here we go. Database error. All right. Now, you have to be able to handle the fact that you're dealing with these nested data structures. I'm having to put my attack payload within the value of this JSON string, right? This is the kind of stuff that we're seeing with new apps that a lot of people are ignoring. You're kind of looking at this whole JSON string, and I'm not going to mess with that. But you got to get in there and actually do it. And your tools have to be able to do it. We've updated our scanner to be able to support these type of environments, but if I'm in here in Burp, it's not handling it for me. If I see my parameters, it's just showing me, in the body field is this thing. It's not separating it down for me. It's not giving me these individual parameters to attack. I have to go in there and do it myself. So it's a real pain. A lot of people aren't doing it. But these are the kind of things we want to replicate for everybody in Hackazon, is to be able to set up all of these different things. We've got a Google Web Toolkit in places. You guys familiar with how that looks? It's like a pipe delimited format. And so it's like, it doesn't have a name and value. It's just value pipe, value pipe, value pipe. And on the back end, it has it's positionally sensitive. And on the back end, it has like the data structure defined there. So that's a real pain. There's all these different formats that we're dealing with. And now let's look at mobile for a second. All right. So here's our little companion mobile app. This is an Android app. So I come in here. It's got the same products. I can come in here, look at the products, see the details, add it to my cart. I can go to my cart, see what's in there, go through the whole checkout process. Actually, this should all be running through burps. Let's take a look here for a second. Uh-oh, I didn't set it through burp. All right, give me a sec. It's my action list. All right, let me set this up. You guys familiar with how to force your proxy in Android?
You got the port?
Huh?
The port?
No. I set the proxy. That was where I set the proxy. Oh, firewall rules. All right, hold on a second. Sure.
Is the Android application itself also vulnerable for anybody that's testing applications?
We're not sure yet. I think we added a few issues with like its data storage, and we actually have the guys at Checkmarks are running some tests on it now. Okay, yeah, so we're in connection, and that should be going through. Yep. Okay, so now let's go back to the mobile app. All right, so let me see. Take a credit card. That's fine. Actually, no. Just do the wire transfer. Whatever. Billing address, keep it the same. And I'll place my order. So all these were, this actually during the checkout process, there's no activity. But after I place my order, you should see something. Oh, there you go. So it's sending the address here in a JSON format, right? Sending the address, and it's putting this into the cart, the items, then it's placing the order, and it's getting these different JSON responses along the way, right? It posts it. One of these should actually show like the confirm, yeah, so created. This is the order. Here's we created, items. But it kind of goes through the whole process, and it's doing a put here. So there's different. This is a get and post usually, and then we add put insert delete, something like that. But you have all these different formats of the data coming in, and eventually it's clearing the cart on the app. And you got a successful order, right? I can actually go and look at my history of all my orders. Here's all the different orders I've placed. And here's the one right now. I ordered that little Martha Stewart thing, right? But all these requests are being done. This is getting my list of orders, right? And this is a simple name and value pair structure. Again, we see a lot of mixing and matching in today's apps. There's some, name and value pairs as gets, some on posts. You might send JSON, you might receive JSON back, you might, send JSON and get XML back. You're seeing a lot of mixing and matching. So again, that's the kind of thing we added here. But here's my list of orders, and it's giving me a JSON packet back with all of the orders that I placed. Then I go and drill into one individual order, and of course this is now a different API structure, right? API order 11, and then it's going to send me that data in JSON here. So we're seeing a lot of this different stuff, and Hackazon allows you to kind of go and actually play with this type of environment. A lot of times, if you want to test this stuff up until now, you've had to kind of test your own apps, and they may not be vulnerable. They may not be the best places. People might not like you doing that. So the final thing I want to make sure we cover is the admin interface. Now this is an online storefront, it's content manager, so it has a lot of the stuff you would generally expect. You can actually come in here and manage your product categories and your products. And this is actually hackable as well. But you can come in and play with the admin interface. But down here, we've got something that most online storefronts wouldn't have, which is the ability to look at your vulnerability config, right? And actually see what's going to be vulnerable here. So actually, let me look at the matrix first. So this is the list of different vulnerabilities that are kind of available, and you can see which ones are enabled or not. You can actually decide which ones, like you might say it's vulnerable to cross-site scripting as reflected, or persistent, right? And so maybe somebody can add something to the, like a product review, and that's going to end up being persistent with the product. Or you just might say it's just reflected. But you can actually pick and choose, which is kind of fun. But you have all these different vulnerabilities to kind of play with, and we're adding more. And so I can come in and say, okay, let's go look at the actual config. Put it into edit mode. And I'll look at the, say the account screen here. But it's actually like a little building blocks. So you can actually come in and decide which fields are going to be vulnerable on a page, and then within that field, is it through JSON, or is it a standard get post? There's a whole bunch of different choices on where this is actually going to be vulnerable. It gets a little complicated. We put some docs together for it. But you can actually come in here and individually decide, right, on the orders page, so my orders, the page is vulnerable, and these are both, the ID parameter is vulnerable to cross-site scripting. So I'll do it that, and I'll do store, right? And now, once I save this, it's actually going to become vulnerable. Right? So you can kind of come in here and play with this sort of thing, and it gets to be kind of fun. Again, especially if you're setting this up for other people and setting up the environment to either teach people or to test your tools. It's a pretty cool way to do this. So I guess that's it. I mean, that's really what I want to cover. We're done a little bit early, but leave some room for questions. But it's pretty simple as far as getting set up. Like I said, it's a LAMP stack. That's why I've been running here on my Windows machine. All right, any questions? Go ahead, Caleb.
Hey Dan, sorry if I missed it, but how long did it take you to put that whole thing together? That looks like a lot of work.
It was a lot of work. I had been dreaming of it since I guess the end of 2013. And 2014 started kind of setting up plans to do it. We started it in the summer, and we basically built it over the last 6 months. I actually had a high school intern start. He was the guy who started it with me, and then I quickly saw I was going to do well beyond him. So I had to hire a couple guys and just putting people to work on it. But yeah, it's 8 months, something like that.
With regards to code base, because you mentioned that the vulnerabilities can be disabled, configured, what have you. For the code paths where the vulnerabilities are exposed versus disabled, is that also revealed in code as well? Like, right, how easy is it to discern the vulnerable versus not vulnerable phase? Because I myself, as a trainer, would love to be able to use that as.
So it's probably not good. Like if you're doing like static analysis, it might be a little confusing because in the code it actually it references like a config for like which filter to apply.
Yeah.
And I guess that's somewhat real, but it's a little different. We like, and that's kind of why we picked the framework that we did. I think PHP Pixie is the framework because it was kind of easy to kind of twist and make it vulnerable where we wanted to. Yes, in code you can actually see, and we have all the places where we expose it to vulnerabilities, and so it's basically, you know, where we're doing the input handling, and then we refer to the config. And it's actually config files, so like when you save the config, if you set it so that Hackazon can write to the config directory, which I wouldn't suggest, it'll go ahead and do that, but otherwise it'll actually give you the files to save, you know, kind of like a lot of content managers like WordPress will give you the WP config to save to your file system. So it'll do that, but it is configurable in code. You can kind of see where it's happening and where we kind of expose things. So like not every input can be vulnerable because we haven't set up every input to be vulnerable.
Yeah, it's just like the use case that I can see for this, for like training developers for like a security mindset, would be to be able to point at where the vulnerabilities happen in code, and if the fixed or correct code is also right there, that you can then compare their solution to the correct path. So that was what I was
should be able to.
Yeah,
I think it would work that way. I'm like turning the code, and I mean it's all kind of sitting there. It's, you know, not exactly like a switch statement, but kind of.
Right.
it's kind of similar to that type of solution.
Okay.
I teach an ethical hacking course, and I'm just sitting here thinking if I let 40 students, you know, unleash on this thing in a lab environment, how easy is it to revert back to a default config?
Yeah, you just go Hackazon/install and kind of run through like 3 steps, and it's resets the database. Yeah. Yeah, we had to because, you know, I have a hosted copy here, right? There's one we're hosting on Hackazon.webscantest.com, and that one just gets trashed all the time. So I have a cron job that keeps resetting that.
Oh, really?
It's terrible.
How vulnerable is the back end?
We haven't done as much testing on the admin interface. We haven't done as much there because we usually block that with like the HTAccess file, and it's got a separate password and everything. So I haven't done as much on that yet, but I imagine it probably is. We haven't you know, I got a few different people working on the code, not just me. And sometimes I look at their stuff and I'm like, oh, this is vulnerable in places it shouldn't be. That's part of the fun, I guess.
On a similar note, so I've been to the PCI lab numerous times for testing out products and ensure that they're PCI certified and all that fun stuff. But talking about the mess that scanners make in tools like this, I'm wondering if you have the ability to delete all that data, is that a realistic setup for a tool? Because in reality, applications like this in the real world are going to have crap all over them. User created content, all these sorts of things. So I'm just wondering, is that something stuff like this should they be deleting content?
That's a fair question. We run into this with our customers all the time, right? People will take our scanner and point it to an app, and I've had instances where people have launched a scan, and I'm sitting there talking with them while it's kind of getting started, and a couple minutes into our chit chat while it's running, all of a sudden, I had one time this guy's office just exploded with noise, and I'm like, what's going on? And everybody was yelling and screaming, and basically there was like a contact us page, and the scanner was attacking that page, and which generated 3,000 emails to the sales team in 2 minutes, whatever, right? And so they're all screaming because their Blackberries are exploding, and and I'm like, well, you got to have some compensating controls. I mean, a kid with a Perl script could do the same thing effectively, right? So if the scanner can do something destructive that, without any intending to do anything malicious, so could somebody with a Perl script that is intending to be malicious. So I usually try to, counsel them a little bit, kind of get them off the ledge, and then kind of say, look, we need to put some limiters in there. But going to your main point, it is absolutely true. I mean, we see this with people scanning forums, and then the forums got tons of crap data. And it's very difficult for them to clean it up, because it might be spread across, a dozen different tables or something. So kind of cleaning up the mess is difficult. But it's much worse for them. I guess I can't think of a way to kind of make that cleanly replicated in Hackazon other than just not, like, what would you do to clean it other than the install, /install. But Chris, you have a question?
Yes, so do you have any plans to add other types of technology in there? So, for example, we see a lot more JavaScript heavy single-page apps coming along, and then there's lots of use of OAuth and things like that. Do you plan on doing that, or are you planning on just handing over to OWASP and OWASP community develop that?
We're definitely going to be adding OAuth for the mobile app. One of the difficulties is I wanted to make it really easy for someone just to grab and go. And if there's OAuth involved, now you got to set up, the providers and the whole, key exchange and all that business. So I wanted to kind of keep that simple, but we're going to have an OAuth option in there, and then allow the user to configure things in the mobile app. So that is coming. Other technologies, there is a lot of AJAX stuff. I didn't really kind of scroll through it, but it is kind of like, it's like one of those infinite scrolling pages where you keep scrolling down and it keeps populating more items. It has a lot of that type of stuff, and we're going to continue to add to that. But I am kind of getting curious, we're probably going to stop like as much active development, with 3 people basically full-time on it, and kind of start seeing who wants to contribute. And I've gotten some people like Greg Foss. He was looking at doing some stuff with it. He's been kind of playing. So, I think other people will start adding, hopefully. And it'll kind of continue living. Any other questions?
Do you have any DOM-based access there?
There is, yes. There's a couple. There's a couple in there. Yeah, there's a couple DOM-based. There's like the Flash applet is also vulnerable. That's where you like enter your coupon code, and you can get the discount, and then basically change your discount and get 99% off and that sort of thing. So you can have fun with some of those things. But yeah, there's DOM-based cross-site scripting. There's some CSRF stuff that we've added, and some broken CSRF models. So there's a couple of different little things in there. But yeah, we want to keep adding. I'm looking at like that list that I showed earlier with that cloud of all the different, like let's say the WASP list. I want to replicate, I would like every one of them to have an example within Hackazon. It'll take a while, but that's kind of the goal.
I may have missed this, and I apologize if I did, but does Hackazon have any of the the traps? Like, you said great. You can't scan what you can't scan when you can't crawl or something like that. Does Hackazon have any of those traps in there?
It's got a bunch. Yeah, and some of them are you've got to get through like a couple Google Web Toolkit ones where if you don't post properly, then you don't get to the next page. And yeah, there's some traps. There's some of the things that we saw in WaveSet, or not Wivet. There's some of the things in Wivet we've kind of replicated or copied over. So we're putting more of that stuff in there. It's not totally crazy though, so most scanners can get through most of it. They just won't be able to attack very much because they won't understand the nested data structures or the JSON or whatever. All right, anybody else? I think we're about out of time. All right, well then, thank you very much.